This is our galaxy. It's a collection of stars, planets, dust, and gas, all held together by gravity. But what if there was more to our galaxy than meets the eye?
What if there was a hidden force that was 6 times stronger than all the matter we can see?
And no, it's not dark energy. Stay tuned, because in this video, we're going to talk about dark matter. I always find it funny when people say things like aliens or dark matter. They don't exist. They're made up. People want to believe them. And from my perspective, that's just as bad as believing someone who claims they have magic powers. You know, it's like how some people will read tea leaves or tarot cards or astrology, trying to figure out their future or the future of humanity. And even though it sounds kind of silly, it's really just people trying to make sense of the world around them. And to the fair, some of those techniques work pretty well at times. I mean, I've seen palm reading predict things with scary accuracy. But the thing is, none of these things are real. There's no scientific evidence for any of them. They're just coincidences or tricks. But with dark matter, it's different.
The evidence
For dark matter,
is overwhelming. We know it's there.
we just don't know exactly what it is. In fact, scientists think that dark matter makes up 80% of all the mass in the universe. So, if that's true, then why don't we know what it is? Well, let me explain. The first hint of dark matter came in the 1930s when Fritz Zwicky was studying the Coma Cluster. The Coma Cluster is a group of galaxies that are all close together and moving around each other. And Zwicky noticed something strange. The galaxies in the cluster seem to be moving faster than they should. Now remember, everything in the universe has gravity, and the strength of that gravity depends on the mass of the object. The more massive an object, the stronger its gravity.
So if you have a bunch of objects all grouped together, like in a galaxy cluster, then the total gravitational force of those objects is just the sum of the individual forces.
If you double the mass of one of the objects, then you double the total force. If you triple the mass, you triple the force, and so on. So here's the problem. When Zwicky studied the Coma Cluster, he found that the galaxies were moving way too fast for the amount of visible matter that he saw. It was like there was some invisible mass in the cluster that was adding to the gravity. He called this missing mass dark matter. But we have way more evidence for dark matter than just that. For example, in the late 1970s, Vera Rubin and her student Kent Ford were studying the rotation of galaxies. As a galaxy rotates, the stars in it move in circles. And again, the speed of those stars depends on the mass of the galaxy. The more massive a galaxy, the faster the stars rotate. But what Rubin and Ford found was that the stars in spiral galaxies were rotating much faster than they should for the amount of visible matter that they had. This was more evidence for dark matter. And in the early 2000s, there was an experiment called WMAP that was designed to measure the cosmic microwave background. The cosmic microwave background is basically the leftover radiation from the Big Bang, and WMAP found that the pattern of that radiation was slightly distorted in some places, and that distortion could only be explained if there was some invisible mass in the universe, dark matter. And here's the thing. All of this evidence for dark matter fits together perfectly. If you look at galaxies, galaxy clusters, the cosmic microwave background, everything, it all fits together perfectly with the idea that there is some invisible stuff making up 80% of the mass in the universe. Okay, so if all this evidence is real, then why don't we know what dark matter is? Well, it's because dark matter doesn't interact with anything. We can't see it. We can't touch it. We can't detect it in any way except through its gravity. So it's like trying to find a ghost. We know ghosts are there. We just don't know what they look like. So what does this mean for the future of physics? Well, it means that we're on the verge of a revolution. Just think about it. For thousands of years, the idea of atoms was considered crazy.
Then Einstein came along and showed us that atoms were real.
And now we're on the verge of showing that 80% of the mass in the universe is made of some kind of invisible stuff. That's a pretty big deal. But the problem is that no one knows exactly what dark matter is. There are a lot of different ideas, but the most popular one is that dark matter is made of some kind of particle. And that particle is called a WIMP, which stands for Weakly Interacting Massive Particle. But we still don't know what these particles are made of, and that's what the Xenon 1T experiment is trying to find out. Xenon 1T is an experiment that's designed to detect dark matter particles. It's currently located at the Gran Sasso National Laboratory in Italy, which is actually an underground facility because you don't want to be detecting dark matter particles when you re-up in the atmosphere. There's too much noise. You need to go deep underground. And the reason you need to do that is because these particles are so weak, they barely interact with anything. It's like trying to pin down a ghost. And the way that Xenon 1T works is really clever. First, they have this big tank filled with liquid xenon, and xenon is a really good substance for detecting dark matter because it is really dense and it interacts with stuff that is not normally visible. And then they put this huge device in the middle of the tank that shoots out laser beams. And here's the thing, when a dark matter particle hits a xenon atom, it knocks it out of the way. And that knocks out a photon, a particle of light. And then the researchers can use the lasers to detect the photon. But the problem is that this is a very rare event. It's like trying to find a needle in a haystack. But after years of searching, it looks like Xenon 1T might have finally detected a dark matter particle. In a paper that came out in July 2023, they reported that they had seen a bump in their data that they couldn't explain. And that bump happened at a specific mass range. That mass range was between 34 and 45 gigaelectron volts. And that's important because it tells us something about the nature of dark matter. You see, in particle physics, mass isn't just a property of particles. It's also a particle. For example, an electron has a mass of about 0.5 mega electron volts. A proton has a mass of about 1 giga electron volt. And the Higgs boson, which is a particle that gives other particles their mass, has a mass of about 125 gigaelectron volts. So, if the dark matter particle has a mass of about 35 to 45 giga electron volts, then that would tell us something about what it's made of. It would tell us that it is probably not the Higgs boson because the Higgs boson is 125 giga electron volts, and it wouldn't be.
So it would be some new type of particle that we haven't discovered yet?
But before you start losing your mind, it's important to remember that this is still just a bump in the data. It could be a statistical fluke. It could be something else. We just don't know yet. But if it turns out to be real, then we would have a much better understanding of the fundamental nature of reality. We would know that there are particles out there that we can't see. Particles that make up 80% of the mass in the universe. And that's pretty cool. And hey, if you're still watching, then you must be interested in space exploration because otherwise, why would you be watching a video about dark matter? Well, so yeah, I hope you learned something in this video. If you did, then please hit the like button because it helps me out a lot. And if you really liked it, then consider becoming a patron. And as always, thank you for watching.